Hello everyone. By the end of this video, you will understand how to solve simultaneous equations using the matrix method. Firstly, both equations in the system of equations must be in the standard format, which is the ax plus by equals c format. Since both of these equations in this example are in that particular format, this can be rewritten in the matrix format as 2, 1, 1, 1. And this matrix is going to be called matrix A. And as you can see, you just get this matrix by inserting the coefficients of x, y, and x and y in equations 1 and 2 in this exact pattern, 2, 1, 1, 1. And that is going to be multiplied by x, y, this matrix. And that is equal to what's on the opposite side of the equal sign of both equations, which is 5 and 3. And this matrix, we are going to call matrix B. Now let us understand how we can solve for this x and y matrix using matrix algebra. So if we rewrite this, we have matrix A into x, y equals matrix B. And now our goal is to actually have xy matrix alone on one side of the equation and everything else on the opposite side so that we can solve for x and y. To do this, we multiply both sides by the inverse of A to get rid of A. Therefore, A inverse into A x, y equals A inverse B. And we know that any matrix into its inverse is equal to the identity matrix I. And therefore, we have I x, y equals A inverse B. We also know that any matrix into the identity matrix leaves that matrix unchanged. Therefore, this entire term just gives us x, y, which is going to be equal to A inverse B. And this result over here is a very important result because this is what we are going to use to solve for x and y using the matrix method. Now let us get back to this example. As you can see, what we need first is A inverse. And therefore, we have A inverse equals 1 over the determinant of A, which is equal to 2 into 1, which is equal to 2 minus 1 into 1. Just multiply the diagonals and subtract. And then we have this matrix a bit modified by basically swapping the two numbers in this diagonal. Therefore, we have 1 here and 2 here. So we swap the positions of these numbers in this diagonal, and the other diagonal is left unchanged with just the signs of each number changed. Therefore, we have minus 1 here and minus 1 here. And this is equal to 1 over 2 minus 1, which is equal to 1. Therefore, we have 1 minus 1 minus 1, 2, which is the inverse of matrix A. And then it's simply a matter of plugging it into this derivation that we have here to get x, y matrix to be equal to 1 minus 1 minus 1, 2 multiplied by matrix B, which is equal to 5, 3. And that is going to be equal to 1 into 5, because 5 plus minus 1 into 3, which is equal to minus 3. And then the bottom, we have minus 1 into 5, which is minus 5, plus 2 into 3, which is equal to plus 6. And this gives us 5 minus 3, which is equal to 2, and minus 5 plus 6, which is equal to 1. And therefore, by comparing these terms, x, the top term, being equal to 2, therefore, x is equal to 2. And comparing the bottom terms, we have y is equal to 1. Let us go into another example to understand this technique more thoroughly. Let's consider the second example with this system of equations. And by looking at the equations, we can see they are already in the standard format, and therefore the matrix A is equal to 3, minus 1, 2, 1. And matrix B is equal to 7, 4. With that, we have this previous derivation where the first step is to find A inverse. So the inverse of matrix A is equal to 1 over the determinant, which is equal to 3 into 1, which is equal to 3, minus 2 into minus 1, which is equal to minus 2. And then we have the rearranged matrix. We swap this diagonal. We have 1 here and 3 here, and keep this diagonal unchanged except for the signs. Therefore, we have positive 1 here instead of minus 1, and minus 2 here instead of positive 2. And that gives us 1 over 5 into 1, 1, minus 2, 3. Next step is to simply plug in these values into this equation that we have over here. Therefore, we have x, y being equal to A inverse, which is equal to 1 over 5, 1, 1, minus 2, 3, multiplied by b, which is 7, 4. And this is equal to 1 over 5 multiplied by this matrix into this, which is basically 1 into 7 plus 1 into 4, which is equal to 7 plus 4, and that's 11, and minus 2 into 7 plus 3 into 4, which is equal to minus 14 plus 12, which is equal to minus 2. And that gives us 11 over 5 and minus 2 over 5. Then we simply compare these terms. The top term is x, and therefore we have x equals 11 divided by 5, and y, which is the bottom term over here, which is equal to minus 2 by 5. I know that the matrix method is not as straightforward as the other methods we learned, such as the substitution and the elimination method. However, this method is very important when solving larger systems of equations and is therefore very essential in mathematics. I hope you understood this video and the technique that we went through in this video. And if you did understand, please remember to like and subscribe to this channel. Thank you for your attention.